Okay, so good day, grade 8 Makati Science High School students. So this is lesson number 2 for our topics in geometry for the first quarter. And our lesson number 2 is all about angle pairs. So we're still going to use the method that we used yesterday, the PUSA. Or sometimes I like to call it the cat method because pusa, cat. So there you go. Problem, understand, solving, and then answer. Okay, so let's try to apply that here on our problem. Okay, so for this one, we have Jasmine was constructing her own lattice framework for her window project in PLE class. Given the illustration below, lines FE and HG are parallel, and so are DC and IJ. So this is FE, and this is HG, and they are parallel. And also, we have DC and IJ, so they are parallel lines. Line BA, okay, line BA, where is line BA? There you go. Is perpendicular to lines FE and HG, so we have right angles here. Okay, and every numbered angle is greater than 0 degrees. So if the sum of the measurement of angles of the measures of angles 21 and 5, so these are the two angles that they're pertaining to. So this is angle 21 and this is angle 5. If the sum of the measurement of their angles is equal to x squared plus 11 degrees, and the measurement of angle 3 here is 9x plus 1. So what is the measurement of this angle? The measurement of angle 10. So for this problem, we're going to be using exterior angles, alternate exterior angles, as you can see here, and also supplementary angles, and also vertical angles. So how can we apply all of those ideas? So we again use the PUSA method. Okay, so we have identified the problem. So this is our problem, and we have also understood our problem. What we're trying to find here is the measurement of this angle, angle 10. Given that we know the measurement of angle 21 and the measurement of angle 5, the sum of their angle is equal to x squared plus 11, and then we also know the measurement of angle 3. So if you remember, guys, one of our theorems about alternate exterior angles, so and also same side interior angles and same side exterior angles. So according to our theorems, alternate interior and exterior angles are always congruent. But what we have here, angle 21 and angle 5, they're not alternate. They're on the same side. Okay, so if they're on the same side, the theorem that we're going to use is of course the same side exterior theorem, which says that the measurement of these two angles is going to be equal to 180 degrees, or they're supplementary. Same goes with the same side interior angles, angles 16 and angle 11. If you add them, that's going to give you 180 degrees. So according to the angle exterior, the same side, okay, same side angle exterior, okay, theorem, we can say that the measurement of angle 21 plus the measurement of angle 5 is gonna be equal to 180 degrees since they're supplementary. And we know that the measurement of angle 21 plus the measurement of angle 5 is going to be equal to x squared plus 11. So therefore, substituting this one, okay, so let's use substitution here. Okay, substituting this value here, so we have your x squared plus 11 is equal to 180 degrees. And if we transfer this to the other side, okay, so this is going to give us x squared plus 11 minus 180 is equal to 0. Okay, so therefore, this is going to give us x squared, okay, minus x squared minus 169 is equal to 0. If you try to factor this binomial that we have, okay, so we can factor this quadratic equation into two simple solutions. So that's going to give us x plus 13 and x minus 13. Okay, so as I said in our video last time, there could be two possible answers for our given values for our different variables. So for this one, it's going to be positive 13 and it's going to be negative 13. But since we cannot use a negative solution for this one, we're going to use the positive solution. So x is equal to 13. Okay, so if x is equal to 13, okay, so therefore we can solve for the measurement of angle 10. Okay, since we know that the measurement of angle 3, okay, the measurement of angle 3 is equal to 9x plus 1. Okay, so that's gonna give us the measurement of angle 3 is gonna be 9 times 13 plus 1. And what's 9 times 13 plus 1? Okay, 9 times 13 is 117 plus 1 is gonna give us the measurement of angle 3 is gonna give us 118 degrees. Okay, so we got x here, 13 from the one that we solved a while ago. Okay, but if you try guys the negative value, okay, if you're going to try guys the negative value, so this is gonna be 9 times negative 13 plus 1. It's gonna give us a negative angle. Okay, and for this one, for this problem, since this is just a plain, a basic plane Euclidean geometry problem, it's gonna give us a negative 116 if we solve for this one. And this cannot be our solution for this problem. So therefore, the measurement of angle 3 is equal to 118 degrees.